Okay, you guys are up here. We have two sections of notes to get through, 5.4 and 5.5. Okay, so.
And that's for a copy.
Hmm?
Can I get another copy of it?
Okay.
Wait. It's actually in my.
You have it?
Yeah.
Okay.
Oh.
That's all right. Okay. Okay, so we're going to deal with inverse functions. We're not going to do this front page. That's a discovering what inverse function is. I'm just going to tell you today so we have time to do the homework. Okay, let's review just regular what we know of inverse. Does anyone know what inverse operations are? Anyone know what inverse operations are? Yep. The opposite. Okay. So what's the inverse of adding, class? Okay, what would be the inverse of dividing? Multiplying. What's the inverse of squaring something? Square rooting. Okay. So that's all that an inverse is the opposite, the thing that undoes it. Okay. So inverse functions are the same thing, but it's an equation, two equations that are opposites or inverses of each other, that undo each other. Okay. If you're just given ordered pairs, like we are at the very beginning, inverse relation, a relation is just a set of ordered pairs. If AB is an ordered pair of a relation, so I have a bunch of ordered pairs, and AB is the ordered pair, then its inverse is BA. The ordered pair is the inverse. Okay, so all it means is that the A and the B, the X and the Y values switch. So if I have this as my function, or my relation in this case, the inverse is just me taking the X values and making them Y values now. And doing the same with the Y's. -2, -1, -1, and 4. So those are my new ordered pairs, -2, -1, -1, 0, -1, 1, and 4 and 3. Any questions over that? Okay, do the next one in your pairs. Find the inverse relation of those ordered pairs. Okay, check your answer. Make sure you got that right. Any questions over that? We're all good? Okay. Now, just for you to really understand what inverses are, I'm going to show you one way of finding the inverse. There's more than one way to find the inverse. I'm going to show you two different ways. You're probably not going to use this way as much as the other way that I'll show you in a second, but this will explain what's really happening. Okay, describe the sequence of operations performed on an input value x by the function f of x. So what it's saying is, what would I do to a number? So say I plugged in 5 for x. If I plugged in 5 right in here for x, what's the first thing I would do to that 5? Multiply it by what? By 3. So my first step would be to multiply by 3. Okay, so that's my first step. After I multiplied by 3, what would I do? I subtract what? Subtract 2. Since an inverse functions are just undoing each other now, to find the inverse, I'm going to describe the inverse of the operation in reverse order. So I'm going to give the opposite operation or the inverse operation and in the reverse order. So I'm going to start now with that one I ended with. So what is the inverse of subtraction, class? Okay, so my first step now is going to be add 2. Then the next step is the inverse of this. What's the inverse of multiplying by 3? Dividing by 3. Any questions over that? Okay, so now we're going to write the rule or the equation. This just means the inverse. Okay, f negative 1 of x is what we call the inverse. So the inverse, I would now take my x. The first thing I needed to do was add 2 to it. So I'm going to add 2. To make sure that I know that that's the first thing I'm going to do, I'm going to put in parentheses. Because order of operations tells me that parentheses go first. So I want to make sure I know that I'm doing that first. I'm putting in parentheses. The second thing I need to do now is divide by 3. So I'm going to divide that whole thing by 3. And now that's my inverse function. That would be the inverse of f of x equals 3x minus 2. Any questions over that? Okay. An easier way to do this is when our equations become more complicated. Another way we can define the inverse is by replacing x and y. So for this first equation, let's just review. F of x is the same as y. They're interchangeable. So don't be confused by that. So I'm going to replace the y value with x. It's going to equal 2. Now I'm going to replace the x with y. Okay, so the first step is switch x and y. My second step now is to solve for y. Because when I solve something, I'm actually doing the inverse operations as I do it. So this becomes easier for me to figure out what my inverse would look like. So from here, I'm going to subtract 3 from both sides. I'm going to get x minus 3 equals 2 times y squared. Then I would divide by 2, divide by 2. Those would cancel out. And I get x minus 3 divided by 2 equals y squared. To undo the y squared, then I square root. And we just finished solving problems where we had to square root both sides. And when I square root both sides, what do I need involved in it? So when I had, let's say, x squared equals 9, and I took the square root of both sides, what was my answer? X equals, and negative 3. So I need a plus or minus sign. So I'm going to get now y equals plus or minus the square root of x minus 3, the whole thing squared. When I take a square root, I need to have a positive and a negative value. And since I don't know all of this stuff, I put the plus or minus in front. Any questions over that? Okay, now we're also to talk about this being a function or not a function. So we're just going to kind of sketch the graphs. If I go back to my original equation, 2x squared plus 3, I can find my vertex here of 0 for x and then 3 for y. This is just shifted up 3, so I can do that. 1, 2, 3. Then my a value is 2, so I have to go over 1 and up 2, over 1 and up 2. So this would kind of be my parabola. Any questions over that? Now I've already stated that from up here, that to find the inverse of an ordered pair, I just switch the x and y values. Because does anyone know how to graph this? What this is going to look like when I graph it? Do we know what the graph of a square root is right now? No. Okay. We are not going to learn how to graph a square root this year. You will learn in Math 3 how to graph a square root. But we kind of want an idea so we can do a little sketching of it by just switching the x and y. So my vertex of this is going to be 3 for x and 0 for y. I switched the x and y here. And then my parabola is going to kind of face this way. It's kind of a bigger parabola, so let's try and do that. Okay. So that would be my graph of my inverse. About. It's not exact. I'm just kind of sketching it. Because it just takes the ordered pairs and switches the x and y values. So do you guys remember the vertical line test and how to identify if something is a function or not a function? Okay, the definition of a function is that for every x value, there's exactly one y value. So when x is 5, you're not going to have 2 different y values for it. Okay, so if we look at this parabola, if I take my vertical line going up and down like this, when x is 1, y is just 1, 2, 3, 4, 5, 5. When x is 0, y is 3. When x is 1, y is just 5, and so on. I could do it the whole time, and I'd only get one answer. So my original equation is a function. But now, if I do that same vertical line test, I take a vertical line, and I draw it through my graph, will I hit it more than once? So let's say that's x is 1, 2, 3, 4, 5. When x is 5, I have a point here for y and a point here for y. So that's more than one y value for an x. So this would not be a function. So our inverse is not a function. Parabolas turned on their side and facing left or right are not functions. So in order, since you don't know how to graph this, and we're not going to really graph this every single time, you just need to know that if it has a plus or minus square root, it's not a function. Because it'll have 2 values for y for an x. You can't have that. Any questions over that? Okay. I'm going to skip down and do G. because G is more complicated. So let's do G together, and then you guys will do F on your own. So we're going to start by replacing our X and Y. So I'm going to get X equals 2 times Y plus 4 squared plus 2. Now we're going to solve. Anyone have an idea what I would do first here to solve this for Y? Yep. Order of operations, exponents first, then multiplication. I would not distribute. And I definitely don't want to square that. Subtract this too. Okay. So I get X minus 2 equals 2 times Y plus 4, the whole thing squared. Now what should I do? Very good. I don't want to distribute that too, because I'd have to square the Y plus 4. Okay, so I'm going to have to divide by 2 next. Okay, so once again, since I'm doing order of operations, I'd have to subtract these, so I can't really divide by 2, so don't try and divide by 2 right now. So I'd get X minus 2 over 2 equals Y plus 4 squared. Okay. Now what would I do? Very good, square root. Okay. And I'm square rooting the whole thing, so make sure my square root covers the whole fraction. Since I took the square root, I need a plus or minus the square root of X minus 2 over 2. This will all cancel out, and I get Y plus 4. So close. Now what do I do? Subtract the 4. Okay, the 4 is not inside the radical, it is outside the radical. So my equation is going to end up looking like this. Y equals plus or minus the square root of X minus 2 over 2, and then plus 4 is outside that radical. Oh, sorry, it's minus 4, not a plus 4. I subtracted it from both sides. Any questions over that? Now, is this a function? No, not a function. Any questions over that? Okay, let's go back and have you guys do F now in your pairs. We replace the Y and the X. Most of us were able to subtract that 5 and get X minus 5 equals Y minus 3, the whole thing squared. Then we square root both sides. And I get X minus 5 inside the radical and a plus or minus sign. Equals, these will cancel out, and I get Y minus 3. To get the Y by itself, I add the 3 to both sides. And then I will get Y equals plus or minus X minus 5. And the plus 3 is outside the radical. I cannot add the 5 and the 3 because one's inside the radical, and it's kind of like a grouping symbol. So you have to do that math first, then add 3. And seeing as though I can't do that math right now because there's an X, I leave it like this. Any questions over that? Okay, is this a function or not a function? Any questions? Okay, let's do the next one. Same steps, we're going to replace the X and Y. So I want to get that y by itself. So I'm going to subtract the 3 from both sides. I'm going to get x minus 3 equals negative y over 2. Anyone know what I should do now? Very good. It's asking me to divide by 2 right now. So to undo that, I'm going to multiply both sides by 2. That's going to give me 2 times x minus 3 equals negative y. I could distribute that and get 2x minus 6 equals negative y. Don't really want to have a negative y, so how do I get rid of negative y? It's being multiplied. Very good. I'm going to divide by negative 1. And I divide everything by negative 1. So I'm going to get y equals 2 divided by negative 1 is negative 2x. Negative 6 divided by negative 1 is a positive 6. So that is my inverse. Is that a function? Yes, it's linear. It's a line, so this is a function. Any questions over that? We're all okay? Okay, last thing is our graphs. I kind of already showed you what your graphs of inverse functions look like. So I want you guys, what do you notice about the two graphs? G of x is my function, and this is my inverse. Okay, so answer those questions for me. Okay, Harrison, what is it, something that you wrote down? Okay, they're both facing towards positive numbers. Positive on the y for the original g of x, and then the inverse is positive on the x. Good. Haley C. Okay, same shape, different vertex. Good. Sabrina, what's something you wrote down? Okay. Left or right versus up or down. Okay, the inverse faces right and left, or right in this case. You're welcome. Anyone else notice something different that we haven't said already? Yep. Same A value. Okay, the A values will be the same. Any other things we can talk about? Okay, what I do want you to notice is if you draw y equals x, that's this graph right here, goes through 0 and has a slope of 1. Draw it in. Remember last year when you talked about transformations, you guys rotated figures, you reflected figures across the x and y axis, you translated up, down, right, and left. Sound familiar? Okay. Inverse functions, their graphs are reflected across the y equals x axis. Okay, not axis, but y equals x line. Okay, so if I folded my paper along the y equals x line, those two graphs would be over each other. Okay. So all inverse graphs have this relationship. It's a reflection across y equals x. Okay. Reflection across y equals x. Okay, the inverse graph reflection across y equals x of the graph of the function. Okay, and is the inverse a function here? Okay, again, if I draw a vertical line, it would cross in more than one spot. So this is not a function. Any questions over that? We're all good? Okay, I'm going to have you guys start your homework, 5.4 homework.